warahmatullahi wabarakatuh. My name is Nusyaira Menti Muhammad Syukri, matric number B0325100181. Today I would like to present our project entitled Hospital Appointment Management System. Hospital manage a large amount of data every day, including patient information, doctor details, appointments, and billing records. When these records are entered manually or using unstructured system, it often results in appointment clash, long patient waiting times, and data inconsistency. Therefore, this project proposes a hospital appointment management database system to provide centralized and structured management of hospital data. The main purpose of the system is to manage hospital appointments and billing records efficiently while reducing scheduling conflict and administrative workload. The scope of the system includes managing patient, doctor, and department information, scheduling appointments between patient and doctors, and tracking billing and payment records. This ensures all hospital data is well organized and easily accessible.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Husaini bin Hussein and I am from S1G1. So my matric number is B0325100251. So today I would like to explain about one of the part of my final project, which is entity relationship diagram. So first of all, we have 5 tables with the title of patient, appointment, billing, doctor, and department. So first of all, we have the patient table, which is the primary key is a patient ID, and the attributes is patient name, gender, date of birth, phone, and address. So the relationship between the patient and the appointment table is one to many. So we go for the second table, which is appointment, which is the primary key is appointment ID, and the attributes is appointment date, appointment time, patient ID, and doctor ID as a foreign key. After that, we go for the table number 3, which is billing table. We have the primary key is bill ID, and the attributes is amount, payment method, payment status, and the foreign key is appointment ID. For department table, we have the primary key for department ID, which is the attribute is department name and location. And lastly, we have the doctor table, which is the primary key is doctor ID, and the attributes is doctor name, specialization, phone, and the foreign key is department ID. So next, we'll go for the business rule. So we have 8 business rule in the project. For number 1 is each patient must be uniquely identified by a patient ID. The second is each doctor must be assigned to one and only one department. The third one, a doctor cannot have 2 appointments at the same date and time. Number 4, an appointment must involve one patient and one doctor. Number 5, a billing record can only be created for an existing appointment. Number 6, payment status must be recorded as paid or unpaid. And number 7, patient and doctor records must exist before an appointment can be scheduled. And lastly, deleting a patient or doctor is restricted if related appointments exist. And also, I will explain about the data dictionary. So we have the patient. So data dictionary include as attribute name, contents, data type, size, format, range, required, default value, unique, foreign key or primary key, and reference table. So you guys can see the patient, department, and also we have doctor, billing, and appointment. So that's all from me.
Good evening everyone, my name is Nurul Ilani Huda, B0325100238. To start, we established our database foundation using SQL data definition language. We've structured 5 core tables to manage our clinic's operation: chairs, patient, department, doctor, appointment, and billing. In these definitions, we implemented strict integrity constraints. For instance, in the patient table, we ensure unique phone numbers and valid gender entries. In the appointment and billing tables, we utilize foreign keys to link patients to doctors and appointments to bills, ensuring there are no data exist in isolations. Once the structure is set, we move to data manipulation language. To manage the actual records, we use the insert statement to register new patients like Nurul Ilani. The update command allows us to change appointment statuses to completed once a visit is over. And finally, delete helps us to maintain the database by removing specific records. The true value of this data comes from our ability to query it. We utilize binary operations, specifically selection and projection, to pull targeted insights. For example, on slide 16, we can perform a simple projection to list all doctor names and their specializations. Alternatively, we can use a where clause to filter for specific needs, such as identifying all female patients for a targeted medical outreach program. Finally, as shown on slide 17, our administrative staff can quickly identify cancelled appointments. This allows the team to follow up with patients immediately, ensuring no one falls through the cracks and maximizing the clinic schedule efficiency.
Good day everyone, my name is Lau Ke. Today I'm going to present the DML select aggregation and grouping operation. And the first query that I chosen is count the total number of doctors working in each department. And the second query is find the total number of appointments handled by each doctor. And then the SQL statement is listed in the slide. The third query for the DML select aggregation and grouping operation is calculate the total billing amounts collected by the hospital from paid bill. After that, the next part is DML select inner and outer join operation. And the first query is list the name of doctor together with the name of the department they belong to. And the second query is display appointment detail together with the names of the patient who booked them. And then the SQL statement is written in the slide and report also. And the third query is show all appointment together with billing detail, including unpaid bill, by using left join. For DML select nested subquery operation, the first query is retrieve the name of patient who have scheduled appointment but do not yet have any billing record associated with this appointment. And the second query is list the name of doctor who have handled more than one appointment in the hospital system. And the third query is display the name of patient who have attended appointment more than one hospital department. And the SQL statement is written in the slide.
In conclusion, the system contributes by improving data accuracy and consistency through a centralized database. It helps hospitals schedule appointments more efficiently, reduce patient waiting time, and ensure proper linkage between appointment and billing records. Overall, the system supports hospital staff and management in daily operation and decision making. However, the system has some limitations. It does not include electronic medical record management and does not support online appointment booking. For future improvement, the system can be enhanced by integrating electronic medical records, enabling online appointment booking, and adding reporting feature for further support hospital management. That's all from us. Thank you.